Have you ever, stopped to wonder how something like Netflix manages to stream your movie, suggest what to watch next, and handle billing all at once?
Right.
Like without any hiccups.
It just works, right?
Yeah, we hit play, and it feels so seamless, but you just know underneath that smooth surface, there's got to be this really intricate structure making it all happen, something invisible to us.
Oh, absolutely. It's a huge feat of engineering. What seems simple to us users is often built on, well, layers and layers of complex systems, all trying to work together perfectly.
And that's exactly what we're diving into today, this kind of intricate structure.
Mhm.
We're looking at microservices, challenges for beginners. It's a neat little 3-page summary, really designed for anyone curious about how software gets built these days,
Mhm.
even if you don't know any code.
Yeah, and our mission today is basically to unpack that, to take what might seem like dense technical stuff about microservices
Right?
and turn it into something clear, something you can really grasp.
Yep.
We'll explore what they are, the specific problems they can introduce, and use some real-world examples just to show why understanding these challenges is actually pretty key to being, properly informed about the tech we use constantly.
Exactly. We're aiming to simplify things, hopefully give you a few aha moments, and, do it in a way that feels like a friend just explaining something genuinely interesting.
Sounds good.
So let's jump in. Where do we start? What exactly are microservices?
Okay, so imagine you're building a big piece of software, maybe like a huge online store.
Right.
Traditionally, you might build it as one single massive chunk of code, everything in one place. We call that a monolith.
Like one giant program doing everything.
Exactly. But with microservices, you take that big application and you break it down into lots of smaller, independent components, services,
Yeah.
and each one handles a very specific job. So you might have one tiny service just for user logins, another just for processing payments, another just for product recommendations, all separate.
Okay, I can see how that might make things more flexible,
Yeah,
easier to update one small part maybe.
precisely. That flexibility and scalability handling more users, those are big benefits. But the source material we're looking at really focuses on the other side of the coin.
The challenges.
The challenges, yes. And it uses this great analogy. Think of a restaurant.
Okay.
That old way, the monolith, is like having one master chef doing everything. Appetizers, mains, desserts, they do it all.
But if they get swamped.
Exactly. If they get swamped or make one mistake, the whole meal can grind to a halt.
Right.
But microservices, that's like a restaurant with multiple specialist chefs. One does only appetizers, another only seafood, one just desserts. Super efficient at their own thing.
But they all have to work together.
That's the tricky part. That specialization demands really careful coordination, so the whole application experience for the user comes together smoothly. And that's where the problems start.
So the first big hurdle is just complexity.
Yeah, sheer complexity. It's not just more pieces to manage, it's managing the relationships and the communication between all those pieces. That number grows way faster than the number of pieces. Think coordinating 2 people versus coordinating 20.
Ah, okay. Lots more potential for things to go wrong.
Right, which leads straight into coordination challenges. These services need to constantly talk to each other, pass data back and forth.
Like the payment service needs to check with the user account service.
Exactly. And if that communication isn't handled perfectly, you get delays or errors. If the main course chef needs something from the appetizer chef, but they're not talking properly, your order gets messed up.
Makes sense. And that must make testing a nightmare.
Oh, definitely. Testing difficulty is huge. You have to make sure all these independent bits work together correctly, especially after one gets updated. It's way more effort than testing one single program. You're testing all the connections.
And the source mentions Netflix here.
Perfect example. They use microservices for, well, everything. Streaming, recommendations, billing.
All those things I mentioned at the start.
Yeah, and coordinating all of that so you don't notice any seams, that's a massive logistical challenge. It shows that, okay, microservices are powerful, but they bring a whole new set of problems that need serious planning.
Okay, so beyond those initial ideas, let's get into the nitty-gritty. What headaches do teams face when they're actually building and managing this stuff, especially if they're new to it?
Right, so we mentioned complexity, but it actually gets deeper during development. That monolith, that single app, it's one code base, maybe one database, runs on, a set of servers.
Simpler to grasp, maybe?
Comparatively, yes. With microservices, each little service often needs its own separate code, often its own database, like its own private filing cabinet, and maybe its own dedicated server.
Whoa, okay. So lots more moving parts to design and just keep running.
A lot more. And then there's how they talk to each other, service communication. They usually communicate over a network.
Like the internet or an internal network.
Right. And networks. Well, they aren't always perfect. You can get delays, network failures. Sometimes data gets inconsistent.
What do you mean by inconsistent?
Like, imagine you update your address on a shopping site. That info needs to get to the shipping service and the billing service, right?
Yeah.
If there's a communication glitch, maybe the shipping service gets the update, but the billing one doesn't immediately. So your next order ships right, but the bill tries to use the old address and fails. That's data inconsistency. Causes real problems for users.
Yikes. Okay. And what about the teams building this?
That's another layer, team coordination. Even if different teams work on different services independently, which is kind of the point.
Yeah, it makes them faster.
Potentially. But they have to agree perfectly on how their services will interact, the rules of communication. If the team building the search feature doesn't sync up properly with the team managing the product catalog.
You search for something that's there, but it doesn't show up.
Exactly, because the services aren't aligned. They're not speaking the same language, or maybe not quickly enough.
And if something does go wrong for a user, finding the problem sounds tough.
It's the monitoring and debugging nightmare. With a monolith, if there's a bug, it's somewhere in that one big code base. Easier to track down, relatively speaking.
But with microservices,
You might have dozens, hundreds of services. Where's the problem? Is it service A, service B? Or is it the communication between A and B? Pinpointing the failure takes way more time, way more sophisticated tools. It's like finding that one faulty wire in a whole city's power grid.
wow. The source uses Etsy as an example.
Yeah, think about Etsy. Product listings, user profiles, checkout, shipping calculation, all potentially separate services.
Right.
Making sure the product listing price is always the same one the checkout service uses instantly, that requires serious effort. Extra tools, constant monitoring, just to manage that communication and keep your shopping experience smooth. It really drives home that microservices, while solving some issues, definitely makes setup and maintenance harder in other ways.
Okay, so development is complex. What about running these things day to day, especially at a large scale, the operational side?
That's where more challenges pop up, especially with scaling and just keeping the lights on for huge systems.
First thing mentioned is cost. Higher costs. That seems counterintuitive, maybe. Smaller pieces.
You'd think maybe, but remember, each service often needs its own dedicated resources, its own servers, maybe its own database licenses.
Ah, okay, so instead of one big server setup, you need lots of little ones.
Potentially, yes. More hardware, more software licenses, more things to manage. So the infrastructure costs can actually go up significantly compared to running one big monolith. That can be tough for, say, a startup.
Got it. And deployment, getting updates out.
Deployment complexity skyrockets. You're not just rolling out one update. You might be updating several services at once, or one service that others depend on.
Right.
You need really sophisticated tools, automation to manage these updates, check that the new versions are compatible with everything else, and do it all without interrupting service for users. Avoid downtime.
And one mistake
Could have ripple effects. An update to the payment service could accidentally break the user profile page if they interact in some unexpected way. It requires extreme care.
And you mentioned databases earlier. Keeping data consistent.
Yeah, data management issues are ongoing.
Yeah.
If each service has its own little data store, how do you make sure critical information is the same everywhere it needs to be?
Like my address again.
Exactly. If you change your address via your profile service, that change needs to ripple out accurately and quickly to the shipping service, the billing service, maybe even a marketing service. That synchronization is complex to build and maintain reliably.
So it's not just coding, it's a whole different skill set needed.
Absolutely. Skill requirements are a big factor. Teams need people who are experts in networking, in distributed systems, in specialized monitoring tools, in advanced deployment strategies. Things you might not need as much with a simpler monolith. It's a steep learning curve if you don't have that experience.
Can we see this with really big companies?
Yeah.
Like the source mentions Twitter or X.
Yeah, think about X. The scale is immense. Billions of tweets, notifications flying constantly. Microservices help them handle that load, but making sure the service that takes your tweet instantly communicates with the service that notifies your followers.
Without noticeable delay.
Across millions of users simultaneously. That requires incredibly complex, real-time monitoring and coordination.
And Uber.
Similar deal. Ride matching, payments, showing cars on the map. all separate services needing to talk constantly.
Right.
And they're super sensitive to network issues. If the communication between the driver's location service and your map display service hiccups even for a few seconds.
The car freezes on the map or jumps around.
Exactly. Which directly impacts your experience and whether you trust the app is working right. Real time is hard.
Spotify, too.
Yep. Managing hundreds of microservices for streaming music, generating recommendations, updating playlists. It requires a massive investment in tools just to track how everything's performing and fix issues the moment they appear.
So, wrapping this section up, microservices give you power, but it comes at a cost.
Definitely. They offer big advantages, especially for large, complex applications that need to evolve quickly. But they absolutely demand careful planning, really skilled teams, and the right tools to manage that inherent complexity. It's a trade-off, no question about it.
Okay, so let's recap briefly. We've gone through quite a bit.
We have.
Started with that initial complexity, the need for careful coordination, like those chefs in the kitchen.
Right. Then the development headaches, tricky communication between services, those debugging nightmares.
Yeah, finding the problem in a haystack of services.
And finally, the operational side. Potentially higher costs, complex deployments, keeping data consistent, needing specialized skills.
It really seems like microservices solve some old problems, but definitely create a whole set of new ones.
That's a great way to put it. It's a different set of challenges.
So, for someone listening, maybe not a developer,
Yeah.
why does wading through all this complexity matter to them?
Well, I think understanding this, even at a high level, helps you appreciate what's going on behind the screen. That app that just works. There's incredible coordination, engineering, problem solving happening constantly to make it feel that way. It helps you understand maybe why things sometimes glitch or why updates take time.
It's like being a more informed citizen of the digital world.
Exactly. Knowing a bit about the invisible scaffolding that holds up so much of our daily lives.
Okay, so before we wrap up, let's leave our listeners with something to think about. A final provocative thought based on all this.
How about this? Given all these technical challenges we've discussed, the coordination, the debugging, the skills needed, what does it really tell us about the human element?
Go on.
You know, the immense amount of human coordination, communication, continuous learning, and just plain problem solving that's absolutely essential to make even the most automated, advanced technology actually work seamlessly for us. It's not just about the code and the servers, is it? There's a huge human system underneath.
That's a great point. It's easy to forget the people behind the tech, the constant effort needed just to keep things running smoothly, something to definitely mull over.